Okay. So let us take a safe like this. Okay. Let us assume that center of gravity is this point. Okay. And also assume this is the point of suspension. Okay. And let us consider the length between a point of suspension and the gravity. That length is L. Okay. So now you rotate this system about this point of suspension. You rotate this your pendulum system or body by a small angle theta about the point of suspension. So if you rotate it, then what will be the scenario? If you rotate it by a small angle, okay, let us consider like this. So this is your center of gravity. This is the point of suspension after rotation. And let us take this angle of rotation, that is theta. Okay, this is the angle of rotation. Now there will be torque and act on this system, and that torque basically will bring this system back. So because of this torque, there will be the oscillation of this body. So if this is the point, then the force or mg will act in this direction, and this angle is how much? Basically this is your theta, and this length is how much? From O to G, that length is L. Now how will write the torque? Torque is nothing but R cross F. Okay, so R is basically the length from the point of suspension to G, the center of gravity. Okay, so that will be your L. And what about F? F is nothing but what? Mg, right? Mg. And angle between this L and G is how much? This is your angle, because R is in this direction and G is in this direction. So obviously this angle will be how much? Theta. So you can write torque will be mgl sine theta. So just you displace this body by a small angle. So theta is so small. So you can write in place of theta, you can write simply theta. What I'm trying to say. So you can approximate sine theta equals to theta. So it will be mgl into theta. So this torque is basically acting in this direction to bring it back. So theta is in this direction. Your torque is opposite to theta. So you have to use on minus sign here. So this is your torque. Please be noted that L you are measuring from which place? So what is the L here? From the point of suspension to center of gravity.
Sir,
yes.
नेगेटिव साइन कहाँ से आ गया ये?
नेगेटिव इसीलिए आया है. नेगेटिव का कॉन्सेप्ट ये है कि your torque is acting in this direction, right? Torque is acting in this direction, and your theta you have taken this direction. So they are basically opposite in direction, exactly same like your spring mass system. So you are displacing your system, spring by an amount of x, and your force is acting opposite direction. That's why you are taking minus sign. So same thing for physical pendulum. Now force is not bringing it back, torque is bringing it back. Okay, so torque is
Yes,
actually
sir.
opposite to that direction of theta. That's why you have to take minus sign here.
Yes, sir.
Now for rotational motion, you know that time period. How will write time period for rotational motion? That is 2 pi square root of what? So when you will deal with rotation, moment of inertia will play that role, same as mass. So you have to take now I is the moment of inertia. ठीक है, डिवाइड बाई के, के इज हाउ मच,
mgl
एल, ठीक है ना। तो आपका क्या चेंज है, आपका रोटेशन के लिए एम की जगह पे आपको क्या लिखना पड़ेगा, मोमेंट ऑफ इनर्शिया, बिकॉज यू नो फ्रॉम द concept of rotation, right? I will play
yes sir
same role as mass. Okay, is it clear to all
okay
what I'm trying to say? And what about L? L you are measuring, L is the distance, that distance is basically from point of suspension to center of gravity. What about I? I is actually the moment of inertia about the point of suspension, because your body will oscillate or will rotate about the point of suspension. So these things you student used to make mistake. Whenever you will calculate I, so I will be the moment of inertia about the point of suspension. Okay. I'll
yes
give
sir
you a question, then it will be clear. Is this concept clear what I'm trying to say?
yes sir
Yes, sir.
Okay. Okay. Now let us take a rod. Its length is L, and let us take one end is the point of suspension. Now what will be the time period? I by, what about mg? Mg then L, right? Is it?
Yes, sir.
So you have I have taken, you see, I have taken a physical pendulum. Physical pendulum can be of any shape. So I have taken a rod, its length is L. On end is the point of suspension. Now if you rotate this rod, it will oscillate. And the time period of oscillation is 2 pi under root I by mgl, right? So what I have given, what is L from that your theory? What is L? L is the distance from point of suspension to the center of gravity. So now it will no longer be L, it will be L by 2, right? Center of
Yes, sir.
gravity will be where? It will be here, middle, right? So this length will be how much? L by
L
2.
by 2.
So you have to take here L by 2. Now what about I? So you know that moment of inertia of rod about the center, it is how much? ml square by 12, right?
Yes, sir.
Moment of inertia of a rod about the center is how much? ml square by 12, right?
yes sir
But you have to calculate about what? About
About
O.
O point.
Okay, then what will be I?
ml square by 12 plus ml square by 4.
Exactly. So you have to use parallel axis theorem, right? So the moment of inertia about this center of gravity is ml square by 12 for rod, but you have to calculate I about O. So it will be basically ml square by 12 plus this distance md square, right? So here d is how much? L by 2. So you have to write ml square by 4. Is it clear?
Yes, sir.
yes sir
Now how much you are getting? So if you calculate it, you will get basically ml square by 3. Okay.
सर
Yes.
सर हम यहाँ L/2 क्यों ले रहे हैं?
That's what I'm saying. You know that moment of inertia of rod about center. It is how much? ml square by 12, right?
हाँ यस सर.
But you have to
नहीं
calculate.
सर मैंने पूछा L/2 क्यों ले रहे हैं?
That's what I'm saying. This distance md square. I'm using parallel axis theorem. So you have to use this length, right? So you are calculating about this. So you have to use this md square. So d is here how much? L by 2. This L by 2 you are taking, right? You are asking, right?
Yes sir.
So so that concept is that L, whatever I have written, that is actually the distance from the point of suspension to that of center of gravity. The center of gravity of rod will be where? At the middle, right? And the point of suspension is one end. So this distance will be how much? L by 2. So whatever you have written for physical pendulum, if you see, if you remember, what distance I have taken? That point of suspension to that center of gravity. That distance I have taken L, right? So if you compare this system and this system. So point of suspension, center of gravity. This distance will be how much? If it is L, total is L. Obviously, this length will be how much? L by 2. Okay.
Okay, sir.
Now, what will be the time period? So 2 pi square root of m L square by 3 divided by m g L by 2. 2 pi, then you will have L will be cancelled. So 2L by 3z, right? 2L by 3z, right?
Yes, sir.
Okay. Is it clear to all? What I am trying to say? Is it clear?
Yes, sir.
Okay. Shall I erase?
Yes, sir.
Yes, sir.
Okay. Now your homework. Suppose you have a disk. This is your disk. Okay. Radius is R. Mass is M. The point of suspension, this is your point of suspension. And that distance from point of suspension and center, that is R by 2. Okay. So you have to calculate the time period of oscillation. Is this question to clear to all?
Yes, sir.
You have a disk system. Huh?
Repeat कर दो sir question एक और.
Okay. So you have a disk. Its mass is M. Radius is R. The point of suspension is here. The distance from the point of suspension to that of center, that distance is basically R by 2. Okay. So this is the point of suspension. Now,
Yes, sir.
the time period of oscillation will be how much? So this is your homework. Okay, please do it.
Okay, sir.
So I can write that answer also 2 pi square root of PR by twice G. Okay. Please do it, huh?
Okay, sir.
This kind of question is very important. Okay, you will get an exam. Are you enjoying class, everybody?
Yes, sir.
Yes, sir.
Okay. सबको समझ में आ रहा है क्लास में?
Yes, sir.
Okay. कोई डाउट अभी तक?
No doubt, sir.
अच्छा. Okay, very good. Okay. Now we'll move to damped oscillator. Okay. Okay. So suppose you have spring mass system. Mass is M. Spring constant is K. Okay. Now if you keep this system inside in some medium, so let us assume your system is in a medium having many number of atoms. Okay. अगर आपने इस सिस्टम को कोई मीडियम में रख दिया है ना, हाँ, and it has many number of atoms, then what will happen? Now if you displace this system by an amount of x. So obviously restoring force will act in this direction, right? So you will have F equals to minus kx. In addition to that restoring force, there will be drag force also, because whenever you have some medium, if you displace this block, then there will be friction force, right? Because you have some molecules. If you displace, the molecule will oppose the displacement. Okay. So due to this, or due to that resistance of this medium, the drag force will act opposite to the motion. So what I'm trying to say, if you keep your oscillator inside some medium, and if you make that oscillation, due to the resistance of this medium, that motion will be opposed by this resistance, and that force basically, that resistance force basically the drag force, and that is FD, damping, that is known as damping force. That will be V times V, where V is the instantaneous velocity. Okay. So due to this, now you see that restoring force and damping force. Damping force is due to the resistance, that is originating due to that molecule, right? Okay, or drag force, and that drag force also oppose that direction of motion. So both restoring force and damped force, they are actually opposite in direction to that of motion. Now net force, how can I write net force? Net force will be, or F, I can write minus kx minus b into v. Okay, here b is damping coefficient, and v is instantaneous velocity. Okay. Now I can write, in place of net force, I can write m del square x by del t square, and that should be equals to minus kx b, then you will have v. V is nothing but del x by del t. Okay. Now if you divide both sides by mass, you will basically get del square x by del t square equals to minus k by m x minus b by m dx by dt. So further I can write del square x by del t square plus b by m dx by dt plus k by m x, that should be 0. Okay. Now let us assume b by m, that is twice of beta, where beta is damping parameter. Damping parameter. Okay. And also k by m equals to omega naught square, where omega naught is your natural frequency. Okay. So if you substitute this b by m equals to 2 beta and k by m equals to omega naught square in your differential equation, so it will become d square by dx square by dt square plus twice beta dx by dt plus omega naught square x equals to 0. Okay. And let us assume this is your equation number 1. Okay. Now, the general solution of this equation of equation 1 is x equals to a exponential alpha t. This is the general solution. Now, if you substitute this x equals to a to power alpha t in this equation 1, what you will get? What will get?
alpha square plus 2 beta alpha plus omega naught square.
So if you do it, if you substitute it x equals to a exponential alpha t in this equation, you will basically get a exponential alpha t will be outside, and you will basically inside you will get alpha square plus 2 beta alpha plus omega naught square. That will be 0. Just you have to substitute this here. So del square x by del t square will becomes a alpha square exponential alpha t. Dx by dt it will be a alpha exponential alpha t. So if you substitute this here in this equation number 1, you'll basically get a exponential alpha t, that will be common, and inside bracket you will get alpha square plus twice beta alpha plus omega naught square, that will be 0. Okay. So from this, what I can write? So from here I can write alpha square plus 2 beta alpha plus omega naught square, that will be 0. Right? So this is a quadratic equation. So the solution will be alpha equals to how much? Alpha will be how much?
Sir, minus beta plus minus root beta square minus
Yes.
omega naught.
So it will be minus twice beta plus minus 4 beta square minus omega naught square by 2, right? So if you solve it, you will get minus beta plus minus beta square
omega
minus omega naught square.
square omega.
Right?
Yes, sir.
Okay. So this is the alpha. So now you can substitute this is the, you have assumed this is your solution, and you got that alpha value. So yeah, you have two roots, right? One is minus beta plus square root of beta square minus gamma, sorry, minus omega naught square. Another root is minus beta square root beta square minus omega naught square. So there are two roots. So how will write that solution? So it will be simply xt will be a1 exponential minus beta plus beta square minus omega naught square into t. And also you have another root, so you have to write a2 exponential minus beta square minus omega naught square into t. So this is your solution. Okay. Now there will be 4 cases. So there will be 4 cases. So when beta equals to 0, beta greater than beta square greater than omega naught square, beta square less than omega naught square. Okay. So there will be 4 cases, and that will decide your motion. So tomorrow we'll discuss, next class I will discuss these things. Okay. So over damping, under damping, and pure oscillation, everything I'll discuss in the next class. Okay.
Yes, sir.
Okay. सर
Yes.
सर आपका ग्रुप कौन सा है सर?
Sorry.
सर आपका नंबर क्या है, फोन नंबर?
फोन नंबर ग्रुप में है, आप ले
सर,
लो। You want
सर
it?
मैं आपके ग्रुप में नहीं हूँ, सर ने ज्वाइन नहीं किया हूँ अभी मैं।
Okay. So shall I write here?
यस
9348 28. Okay. समझ में आ रहा है क्लास में आप लोगों को?
यस सर।
Yes, sir.
Okay. लिख लिया आपने? Have you written?
यस सर।
Okay, we should stop here. Okay.
ओके सर।